A well-written test case should be portable and reusable. A user should be able to easily run a test case in multiple environments. We will achieve this using parameters, topology properties in TBML commands, variables, and field substitution. Parameters provide a way to abstract commonly changed data from the test case, like the expected firmware value shown in this example. They are easily changed by the user and can be checked before each run. They can be stored in the test case on the parameters page or in a separate parameters file. Parameters are referenced in a test case using the syntax shown here. An easy way to generate this code is to use the Insert menu found by right-clicking in the description field of a test step. Topologies can store device info using custom properties. Test cases access those properties using TBML commands. These can also be generated using the Insert menu found by right-clicking on a step. Use topology properties and TBML commands to supply the test case with info that changes when you change the test bed. We'll now look through our test case and identify any hard-coded information that we want to replace with parameters or topology properties. If I look here on my Show Chassis Firmware step, I don't see any hard-coded information in the command, but I do see it here in the analysis rule. The analysis rule is looking for a hard-coded firmware version. If I look at my Show Interfaces Brief step, I see that the interface name for our primary interface is hard-coded. First, we'll focus on the hard-coded firmware version. This is a good candidate to be a parameter because it's something the user will know before the test starts, and it's not something that's going to change every time we change the topology. So I'm going to go to the parameters page of my test case and create a new parameter. I'm going to name that parameter expected firmware. Going to leave a good description so anyone running this test will know what the parameter's function is. And I'm just going to copy and paste the value into the new parameter. Back on the steps page of my test case, I'm going to look for anywhere in the test case that has the hard-coded firmware version and replace it with the parameter function. So here I can see on my assert statement, I have the hard-coded firmware version, so I'm just going to highlight that text, right-click, choose Insert, and then Parameter. I can see a list of the parameters I have defined for the test case. Of course, we only have the one right now, so I'm going to choose that one, expected firmware, and click Insert. Now that's been dropped into the assert statement here, and this is going to be just replaced with the value of the parameter when the test case runs. So it should work just as it did before. Let's take a look at the other piece of hard-coded information in our test case, the interface name of our primary interface. Now we could make this a parameter, but this is really tied to the test bed we're using, meaning that every time we change the topology, we're going to have to also change this parameter. So that makes it a good candidate to be a topology property. Let's take a look at our topology file, and then at the .dot device in that topology file. If I go to the properties view down here in the bottom right corner, I'm going to see we have all the properties listed for that device. So since we're talking about a port here, I'm going to add a port by clicking the little drop down icon next to the plus sign and clicking add port. If I come in here, I see there's a few properties already associated with this new port. So we're going to name the port primary interface. Now this is the generic name, very similar to how we named the device DUT earlier. It refers to the role that the device plays in the test case. The property called inventory name is where we're going to add the actual name of the interface. So GE000. The reason these two name properties are present is because if you use velocity, this is how velocity handles its generic role names and its actual device names. It has a name property for the role name, just like we're using it here, and then the inventory name is going to be whatever resource is chosen. So if we keep it consistent with this, in case you use velocity in the future, it'll still work using this format. Let's save our topology file. Now we can replace the hard-coded interface name with a TBML command that will reference the topology property that we just created for that port name. So I'm going to just highlight the hard-coded port name, right-click, choose Insert, and TBML command. We're going to find a property value, so I'll leave that first option selected. Click Next. We're looking for a property on a resource, so I'll select that option. And we're going to look for it by name. So if I expand our DUT resource, I will see the port that we added to that DUT. And if I click Next, we'll see the list of properties that are attached to that port. We're looking for the inventory name, so I'll select that property and click Next. This next page we can ignore. I'll hit Next again. And now we can see the TBML property command that the wizard has generated for us. So let's take a look at that. TBML is the function that we are executing. We're looking for a property. We're looking for it by name. And this is the name of the resource that we are looking at. So DUT space primary interface. And then this last one is the property that we want to get the value of. If I click Finish, it's going to insert that here. And it inserts it wrapped in square brackets. What the square brackets mean is that it's going to execute whatever's inside the square brackets as a Python function, or if you're using Tcl, as a Tcl function. This TBML command is actually a Python function, so we need it to be executed as a Python function within our regular text show interfaces brief command. Information learned during a test run can be stored as a variable. Here you see an example of how a variable is created and used. Variable names must follow these rules and must not overwrite a reserved variable name. Reserved variable names are used by various functions in iTest and could be overwritten. Of particular interest is the variable value. This is the variable created whenever a query is made by an analysis rule. Let's take a look at how the value variable is used and how we can use it to improve our execution messages in an analysis rule. Here in the analysis rule for our show chassis firmware step, remember in the show chassis firmware step, we had to look for a substring in the larger version string given to us by the version query. We accomplished this using a Python function on the value variable, as you can see here in this assert line. Now, the value variable is going to be whatever the latest query result was. So in our case here, the last query we did is the first version in our response here. So the value variable is going to be equal to this whole string. And here in the assert line, we are saying find the firmware version within this string and tell us the position of it. So here you can see how the value variable is used in an assert step. In a simpler example, down here in our show interfaces brief command, you can see here that we're looking for the physical status query. So just show me the link status of our interface. And here we're saying, tell me if the value variable is equal to the string up. So let's go back to our show chassis firmware step, and let's see how we can improve our execution messages. So right now, these values are hard-coded. So I could replace this with a parameter function. And I could replace this with a parameter function too. But we want to give a little more information here. We want to tell the user what the DUT was actually running. So I can do something like this. I can say DUT is running firmware version value expected, and then the parameter. So now the user can see that the test failed. They can see that it failed because the DUT is running a different firmware version from the expected firmware version. Now we're going to create our own variable. You can see in our show interfaces brief step that we're using a tbml command to reference the port name from a topology property. Now there's a couple other places we could use that, right? We could use that in our execution messages to make these a little more informative, tell the user which interface the primary interface is going to be. But we don't want to necessarily use this long command again and again throughout each of these steps. So let's come up here and create a new step to create a variable to hold this information throughout the whole test case. The first thing I'm going to do is create a new comment. Now I'm going to create a new step inside this comment, so I'm just going to indent it over. Now we're going to change the action here from comment to eval. An eval step is going to execute whatever is in the description field as Python or Tcl, depending on the language you have selected. In our case, it's going to be Python. So I'm going to create a variable called primary interface name. I'm going to drop in the tbml command here. So I'm just going to copy that, paste it here. So now we're going to have a variable called primary interface name available throughout the test case that's going to have the information here. So all I need to do is change this out to the name of our variable, and then I can use this variable again and again throughout the test case. If I save the test case and run it, we're going to see in the report that the parameters and variables and topology properties have been inserted into the test case. So here's where I create my variable for the primary interface name. I can see here in this execution message and in this step that we're substituting the parameter for the expected firmware with the actual value of the expected firmware. And here in the show interfaces brief step, we're using that interface name that we're getting from a variable and from the topology property. We've seen in our test case development that parameters, TBML commands, and variables are sometimes inserted into steps using square brackets. This is called field substitution. Field substitution allows these types of data, or in fact any Python expression, to be added to any step that supports it. Throughout iTest, some text fields include a small gray box. If field substitution is enabled, a small f will show in the box. This can be toggled on and off. When field substitution is enabled, anything in square brackets will be executed as a Python expression. Some steps, like eval steps or assert steps and analysis rules, already expect the description field to be a Python expression, so field substitution is not needed. You will not need to use square brackets in those steps. Let's look at an example of field substitution being used in our test case. Here in the analysis rule for our show interfaces brief step, we're using the primary interface name variable in our execution messages. So if I click on that execution message, take a look at the properties menu, I can see that field substitution is enabled for this message. So now with field substitution enabled, we've seen that when the test case prints this line, it substitutes the value of the variable here for the text primary interface name. So instead of seeing primary interface name, we're going to see, in our case, GE000 being the name of the interface. If I disable field substitution by clicking this little box, we're going to see that the test case is going to print this as literal text. If I save and run my test, we can see in the execution message that field substitution being disabled, it now actually just prints out the name of the variable instead of the actual value of the variable that we were looking for. I'm going to close my test report, and let's take a look at a step that doesn't require field substitution to be enabled in order for a Python function to work. So if I look at the eval step here, you can see we're using a TBML command, and we're not using any square brackets here because eval steps are already assumed to be using Python. If I look at the step properties for that step, I can see that there's no option to enable or disable field substitution. So anything you have in that step is already going to be executed as a Python expression. Let's take a look at an assert line too. If I look at the assert line in my show chassis firmware analysis rule, I can see that we are doing a parameter function also without square brackets. So similar to an eval step, anything in an assert line is already assumed to be a Python expression. Interestingly, however, I can disable the field substitution in an assert statement. Our test case is now portable. There's no hard-coded information anywhere in the test, so if we're going to run this on a different device or even on the same device with a different interface name or a different expected firmware value, we could easily change those in the parameters page or in the topology properties.